Hi guys, good afternoon. Welcome to our discussion. This is actually a supplemental explanation of the module that was given to you. This is on the course Database Management System 1. So this afternoon we will be talking about different topics that is related to database management system. This is also stipulated in your module 1. So, database management system. The definition is collection of interrelated data. So, database management system that is composed of different data that is placed in a particular table and related to each other to become a database. It is also a set of programs to access the data. So there are a lot of programs that are being used to access the data as front end, because database is considered as the back end of our database system. And there are programs that are being used as front end of accessing the data. Let's say for example the PHP, the Java, the Visual Studio, and other programming languages that involves database that are using also database. So the DBMS contains information about particular enterprises. So the database management system is actually having or storing different information that are useful for their company or an enterprise. So it also provides an environment that is both convenient and efficient to use. So the database management system offers fast and easy for the users to manipulate and easy for using. So database application example are for banking, airline reservations, schedules, university registration, grades and others, sales, customer product purchases, manufacturing, production, inventory, and human resources. So all of these are having database application that is for the purpose of having an effective and efficient way of treating the data. So when you're going to use database, everything will be okay and it will save time also. So database touch all aspects of our lives. So the purpose of database. In the early days, database applications were built on top of the file system. So when we talk about file system, that is prior to the database management system that is being developed. So drawback of using file system to store the data. So these are some issues concerning the file systems. So data redundancy and inconsistency. When you say redundancy, data that are being stored in a particular system sometimes repeating or duplicating, and inconsistency meaning there are some problems or let me say errors when it comes to the content of the data. So multiple file format, duplication of information in different files. So if that issues are actually present, then your performance, the performance of your system might be affected due to the bulk of data that are stored. Okay, so difficulty in accessing the data. So it is quite difficult to access the data because you're going to manually retrieve the data, or you're going to manually check or to find the data. Okay, need to write the new program to carry out each new task, and then data isolation, multiple files and formats, Then integrity problems. Okay, integrity problems. Integrity constraint. Let's say, for example, account balance is greater than 0 becomes part of the program code. So it is hard to add new constraint or change existing ones. So there are problems when it comes to the integrity of the data. Okay, the validity. Alright, the purpose. Some advantages of database management system. So this is a comparison of the file system and the database management system. As I've said, file system that is being used prior to the database management system, which is we are trying to compare which is better, the file system or the database management system. So advantage of having the database management system is minimize redundancy and inconsistency. So this is actually the answer to the issue that is found in the file system. So minimize redundancy. It is not totally, the database management system is not totally demolishing the redundancy issue and inconsistency, but then it really normalize or minimize the issues that are found in the file system. So normalization process is one way of reducing redundancy in your database. Okay, for example, student information can be held at one place in database and accessed by different users. So meaning, using the database management system or the DBMS, you can only store data in a particular table, and not that particular data will not be repeated to another table in the same database. So that is why there is the presence of redundancy or minimizing the redundancy of data. Simplify data access. So the user needs to use, or the user needs only name of the relation, not exact location, or to access the data. Meaning, accessing the data using the database is you just simply have some fields, specific fields that are considered unique and has a link to the different tables in order for you to access all of the necessary data that you wanted to access. Okay, it is simplified, which all you have to do is to address the unique field connected to the different records. So there is interconnectivity. So multiple data views. Different view of the same data can be created to cater different user needs. So multiple data views. So anybody can cater the needs from the different users. For example, you have different terminals. Then if you wanted to access different records at the same time, you can do using the database management system without having traffic. Okay. Data security. Encryption features hinders unauthorized users to access the data, and the database encryption features, meaning data security, one of the very issues that are present, experienced by different companies, is security. So that is why DBMS or database management system are actually having that features for security purposes, that those data will not be easily hacked by some people, meaning that will not be unauthorized access. Why? Because of encryption. Encryption is a process of converting the data into different formats with an applied algorithm. So it is quite difficult to decrypt the file. So database minimizes security access to data. So concurrent address to data. Different users can access data at the same time in DBMS. So as what I have said a while ago, that if you are trying to access the data in the server, and then other also would try to access the data in the server, provided that they are connected and they have the authority to access, then at that specific time you can make transaction to the database. Okay, backup and recovery mechanism. So the database allows users to back up manually or to create a developed system to perform backup over a specific period of time or a period of data automatically. So you can have in your database management system, you can set backup of your file or your database at a specific period of time. Let's say for example you want that your system will have to perform backup of the records that is being stored into your system every Sunday or every Saturday. So your system will continue to perform that task being assigned to that particular function and will have to back up the data. Okay, so by that backup, if something happens to your system, then you can import the data and then that will be used as your current data. So that is the beauty of database. So entity relationship model. Example of schema and entity relationship model. So these are this figure shows the table and the relationship of the different tables. So this customer and the account is representing the tables. This is the entity, the depositor, and this one, the customer name, the customer ID, customer street, customer city, account number, and balance are what you call the field in the table. So meaning the table comprises of different fields to form or to store a record of a particular entity. So si depositor has a customer name, has a customer ID, has the address and the account number. So depositor is identified according to the account number. Okay, account number, which is also connected to the customer from the account, is connected to the customer using the account number or the customer ID. Okay, so that is why they are related. The account and the customer is related by means of a common field that they are sharing the same data. So that is how the data is being connected from this table to another table. That is what you call entity relationship. Okay, so entity relationship, ER model of real world entities or the objects. Entities may be a particular customer, okay, account, or a bank. That is entity. Relationship between entities, example, account A101 is held by customer John Johnson. Okay, so the field or the particular data that is linked to the account number this 101 is connected to another table having this account number. Okay, that is how they are related from each other. So a collection of tables that is actually considered a database, which the table is composed of different fields. That fields will have to store the records of a particular person, like for example name, account ID, address, and then the other table there is also an account ID that is related to the first table, and so on and so forth. So widely used for database design. So the database design ER usually converted into design and relational model. So they are actually, there should be coherence, no? Whatever found in the ER, that is converted into the relational model. Okay. So relational model, example in tabular data in the relational model. So customer ID, customer name, customer street, customer city, and account number. Okay, so the account number in another table should have account number for them to be connected. Okay, that is establishing the relationship from one table to another. So this is an example of relational database. So in the first table, which is found at the upper part, the customer table, we have here the account table, we have here the depositor table. Okay, how are they related from each other? Okay, so in the first table, customer table is linked to the depositor table, having a field which is the customer ID. Okay, so the customer ID here, okay, and the customer ID that is found in the depositor table is connected. So let's say, for example, if you wanted to search the customer ID 192-83-8465, when you are going to do search of that, that will be redirected to the customer ID of the depositor table. Okay, what we're trying to get from this particular ID, we are going to check how much is the balance of this account. So the balance of this account is coming from the account table, which is account table is having only the account number and then the balance. So meaning, when this table is establishing already connection, this table will have to establish connection through the account table using the account number also. Okay, so because of this is connected to 7465 for the depositor table, and the account number of this ID number is A-101, which is having this A-101 in the account table having the balance of 500. So that is how they manipulate the data and how they connected from each other. So definition, data definition language, DDL. Specification notation for defining the database schema. Example, create table, account number. So this is what you call the process of defining. Okay, when we are going to create our table, we have to define our fields, which is this one. This is our field. This is how we are going to define the schema. Okay, the schema of a particular table or a database. So how are you going to describe account number? Account number should have a character data type and having 10 values maximum. Balance is an integer. So when we talk about integer, that talks about numbers. Okay, meaning when you are going to create a table, you should have to specify what particular field are you going to incorporate in that table and what are particular data that you are going to put into that particular field. Okay, so that is why we need to define our field names, and then we need to define the data types and the content of that data types. How many characters does this account number should store or should hold? And same is true to balance. And if you have several fields that should be incorporated in this table, then you just have to separate that by comma. Okay, until such time that everything is done, then you're going to save, or you are going to press go. Then the database or the SQL will have to generate the table for you. So DDL compiler generates a set of tables stored in the data dictionary. Data definition language will have to generate. Okay, the compiler will have to compile your statement by having the definition language into an actual table. Okay, so data dictionary contains metadata about the database. Okay, data dictionary. So if you're going to access the data dictionary of your tables, then you could see the different attributes of that fields in a particular table that you've created. Okay, so data manipulation language for accessing and manipulating the data organized by the appropriate data model. So DML. What is DML? Data manipulation language, also known as query language. So from the word manipulation, okay, manipulating the data. How are you going to manipulate the data? So you are going to perform now the queries which will direct the computer to do or perform some function for you to generate the data from the table that is part of your database. So two classes of language. First is procedural. So procedural, users specify what data is required and how to get those data. Meaning when you say procedural, that is somewhat manual or something like that. You are going to specify everything. All of the instructions should be placed and before that will be executed. But non-procedural, you are just to specify what data is required without specifying how to get those data, because in the non-procedural, as a programmer, you are not going to be concerned on how to do it, but you are just to be concerned on what particular data that you are going to get. So there are simple syntax or pattern that you are going to put into that statement, that it is this SQL to perform on how to do that. Alright, so SQL is the most widely used query language. So structured query language, that stands for S, structured, Q, query, L for language. So that is why we are using MySQL. Okay, MySQL. Okay, SQL while used in non-procedural language. So example is select customer name from customer, where customer ID is equals 192 blah blah blah. Okay, I will explain. Anyway, there will be a specific session for the DML and DDL, definition language, how we are going to define a particular table, how are we going to create the database, and we'll be having a separate session on how to manipulate the data that is placed in our database. Okay, so this statement alone is actually coming from our table. The first one, the customer here, that is talking about your database name, followed by that. Okay, and then the next customer is your table, customer name is your table name, or the field name, and then from your table name. So select select customer name, or you can say select customer name from customer. That's still okay. So customer here, this is representing the table. Customer name is representing the field in that particular table, and from where you are going to get the customer name, that is coming from the customer table, where the customer ID is equal to this value. So the database will have to look into the data from this table where having a value of 192.83.7465. So that is how the database function. So it is not, we are not concerned on how this database will have to find the data, but we are just directing the database where to get and what values should be compared to the data inside your table or inside your database. So application programs generally access databases through one of language extension that allow embedded SQL or application program interface. Okay, you can generate the data from the database using the SQL alone, or you can use a specific program as your front end, meaning we are going to combine two programs in order for us to manipulate the data from the database. So there is already the presence of the back end and then the front end. Back end is your MySQL, and then the front end is another program, like for example the Java, another is the PHP, another is Python, and so on. A lot of programming language that can manipulate the database. Okay. So database users are differentiated by the way they expect to interact with the system. So application programmers, so these are the programmers that is focusing on creating interaction with the system. So application programmers, they are the people or the person that is creating instruction what particular data that we're going to get. Okay. Sophisticated users from or form requests in a database query language. Okay, so they are higher level programming language, or they are programmers that creating sophisticated libraries or something like that. That is for the purpose of requesting data from the database. Okay, that is their function. Sophisticated users are creating a particular library or functions that will have to perform the request from the application programmers. Specialized users are to write specialized database applications that do not fit to the traditional data processing framework. So they have their special function. Okay, let's say for example there are issues on compatibility, so they have to make some ways that would solve a particular issues. So naive users invoke one of the permanent applications that have been written previously. So naive, these are users that are actually, let's say for example person that are trying to access data or database over the web, bank tellers, or let's say for example we could say hackers. Okay, they're trying to access database without asking permission from the database managers. Okay, so the database administrator coordinates all activities of the database system. So the database administrator, this is the one that administers, from the word administrator. So the duties include schema definition, storage structure, access method definition, granting user authority to access the database, specifying integrity constraint, acting as liaison with the user, meaning liaison, you are trying to give some information how, what, and who are accepted in that particular database for accessing. Okay, monitoring performance and responding to changes in requirements. So those are the functions or duties of the database administrator. So transaction management, we say transaction is a collection of operations that performs a single logical function in database. A transaction is a particular action, okay, or an operation. Let's say, for example, you wanted to get data from the database that will help to generate a report on analysis of the sales. That is transaction. Okay, transaction management component ensures that the database remains in a consistent or correct state despite systems failure. Okay, the transaction management will have to ensure that everything is okay in spite of the fact that there are problems that may occur on the process. So concurrency control manager controls interaction with the concurrent transactions to ensure the consistency of the database. Okay? Consistency meaning consistent at the same time coherent. That is talking about the database contents. The storage manager is a program module that provides the interface between the low-level data storage in the database and the application program query submitted to the system. So the storage manager, that is actually referring to the system itself that is managing how the data is being stored in your database and how the data is being performed or how the query is being submitted to the system. Okay? The storage manager is responsible for the following tasks: interaction with the file manager and efficient storing, retrieving, and updating of data. So meaning the computer system itself has the storage management. Okay, that is the system will have to communicate with this manager in order for the efficient storing and retrieving and even updating of data from your storage. Okay, because our data in the database is being stored in our computer system, so there are storage managers that will have to manage how the data is being stored. Okay, in here this is the overall system structure. So this structure, the naive user, the application programmers, sophisticated users, and database administrators, up to the last point, which is the database or the disk storage. So that is how they work. So from the physical or the persons or the entity to the application programs, up to the system programs. This is the function of the operating system, and we have here up to the storage of the computer system. So application architectures. So user, application, network, and database system. This is a two-tier architecture. Okay, then user in here, application client, network, application server, and database system. This is a three-tier architecture. So the definition says two-tier is a client programs using ODBC or JDBC to communicate with the database. So meaning it is just simply a standalone program that the database is in the system and then the program is also residing in that particular system, and here distributed, meaning there is a server that anywhere in the different locations you can access the database. Okay, that is three-tier. So I guess that ends the discussion of that. Is just a supplemental, as I've said, that is just a supplemental discussion of the module that was given to you. And the next video that I'm going to share with you is all about what is the difference between the data definition language, the DDL, and the data manipulation language, how these two differs from each other. So on the next video, we will be having to perform the statements under the data manipulation language and then the data definition language. So thank you very much, and I hope that you get something in relation to our topic this afternoon. Thank you very much, and God bless.